it in Python. The purpose of this talk will be like a general introduction about functional programming and how it can be implemented in Python by itself. We won't get too deep in the concept of functional programming, but we will take a general overview and how these elements and with what functions we can use in Python to leverage this style of programming. Before we start, let me introduce myself. I'm Alexander Mejia, as someone already mentioned. I'm from Ecuador. I'm a software developer. I'm fairly new in the software development world, but I had the opportunity to work in many languages, both professionally and in my own time. Currently, I'm working with Haskell, but I also have worked with Python and JavaScript professionally, and I have dwelt in C#, C++, and Java on my own time. Well, I also enjoy a lot of video games. But yeah, that's all about me. Let's go ahead and talk about the topics. So what are we going to cover today? Well, today we are going to have a general introduction of functional programming as a concept and some of its principles. I'm going to focus mainly in what is pure functions, immutability, and higher order functions. And then with these principles, we're going to match them on how we work with them in Python. We'll take a look at some of the challenges and also how we achieve them in general. Later on, we will talk about commonly used functions that exist in Python that help us use these principles and also help us build software using functional programming. Later on, we'll talk about a specific concept in Python, which is called comprehensions. And finally, we'll talk about some considerations that we have to take into account when we work with this style of programming in Python. So let's go ahead and get started. So what is functional programming? Well, functional programming is a programming paradigm that is based in the composition and application of functions. When a language is fully functional, that means that everything that it has is functions, and everything that it uses are functions. And it works with these functions together to have a functional software that works. These functions have a very specific definition in the sense they can be considered something like a box that does something, and it presents an input and an output. And these behaviors should always be consistent in the sense that an input should always return the same output. To have fully functional programming language, we should have some principles that we follow. These principles can be uses of pure functions, immutability, higher order functions, partial application, lazy evaluation, pattern matching, and sometimes type checking. These are not all the principles, but they are the main ones that you will find in most functional programming languages. We are not going to focus on all of them, as there are quite a lot, but the first three are the main ones, and they are more than enough to apply them in a language that usually is not functional by default. Before we go ahead and explain about these principles, let's take a look at some of the functional programming languages that exist and some of the languages where we apply some of these principles. Also, some popular functional programming languages like Haskell, Elm, Elixir, F#, Common Lisp, Bludger, they usually apply all of the principles I mentioned before. And again, as I mentioned, here in these languages, everything is a function and everything works with functions. Now, to apply functional programming in more common languages, usually these languages that help us apply these are called multi-paradigm languages, and they have many utilities and helpers that allow us to apply functional code in general. Some of them can be Python, JavaScript, Java, C#, but also you may find the ability to apply functional concepts in languages like C++ or something else. So yeah, that's pretty much it about functional programming in general. Let's go ahead and jump in the principles I mentioned. So we were going to talk about three ones: pure functions, which means that a function with an input always returns the same output and there are no side effects. We have immutability. That means once something exists, it cannot be changed. And finally, we have higher order functions, which means that a function can receive and return other functions. So let's go ahead and dive deeper into each of these principles. We have pure functions. So let's imagine, as we have in this graph, we have a specific input, and it goes inside the function does something, and then returns an output. And there should be no side effects. So something like this is part of the graph is not at all. So what is a side effect? We can consider a side effect as any operation that is being done outside of the context of the function, but affects the function, or the function uses it to affect something else besides the output. A side effect can be considered something like a call to a database, reading from a database, writing or reading a file, or even having a print statement somewhere in the code. So how does this work in Python and how can we achieve it? Actually, pure functions in Python are actually quite simple to have. We can have this definition here. It's a quite simple function. We call it power of 2. And what it does, it receives an input x, and then it elevates x to the power of 2. Quite simple. And this function is pure, as we can see, because it's very consistent in its behavior. We have an input and always the same output. And we don't have anything on the side that is happening. Also, as you can see, this can be very easy to test because the consistency allows to create test cases that are quite easy to understand and follow. But let's take a look if we modify this function in a simple by one small thing. We remove the input, and we have right now it doesn't have any input, and instead we have a y value that is declared outside of the function, and the function changes this y value here, elevated by the power of 2. Now this function here, by this definition, becomes impure. The reason is that the output becomes inconsistent with the input. When we don't have any input, now we can have multiple different outputs depending on an external value of the function, which is y, as it's not in the same context. That is something we should try to avoid when working in functional code, as it can become very hard to manage, in the sense that if we don't know where y comes from, or something happens outside of what we expect from y in this case, as the number changes here, it will be harder for us to understand what is happening here in the function. And then later on, it will be harder to debug or test. And let's take a look at final modification to this function. It's the same function as the first part, but now we have added a printing statement. That's what we call a side effect. So why this print here is a side effect? It's quite simple because print calls the input output or program to then bring something into the console. While this change is fairly innocent and may not have many issues, we just have to take into account that we are modifying something external of the context of the function. This will be much serious if we had something like reading or writing a database, as we're modifying something that is outside of the scope of the function. So you may wonder, if we are only restricted to do something like this, which is quite simple, how are we able to build a software that interacts with other parts of our machine or talks with other systems? So the idea is that with pure functions and with software that tries to use pure functions, is that we try to separate all the side effects from somewhere else than all the pure functions that we have. That way, it will be much easier to manage any side stuff or unexpected stuff that may happen, and most of our functions will be behave as expected. So yeah, that is pretty much it about pure functions and how they are applied in Python. Let's take a look at about a more complex principle and maybe a bit more of a challenge in Python, which is immutability. So immutability is the property of a value that once defined, it cannot be changed. In Python, we actually don't have a way to say, okay, this value cannot be changed. We cannot restrict that by itself. It's something that's going to be your responsibility as a developer there. But we can still apply it in the sense that we keep track of it. It should be good enough. So what does it mean it cannot be changed? So for example, we have a declaration. We cannot, this same declaration of a value, change it in that value. So the same value cannot have a different, something different later on. If we want to make a change, we actually have to have a process where the value is passed to something like a function or something like a constructor that creates a new value that is entirely new, creating another copy with a different information to end up being with two different values. So let's look at a simple example here. We have a text, which we have defined as a string hello. And then if we want to maintain immutability, what we have to do is that we declare text2, which will have the same element, and then we can add anything else. That way, we have a modification of the information at the start, but it's entirely in a different place, in a new variable, which has the now value hello world. Now, if we break this immutability, it will be something like the code below. We have text2, which now we are declaring as text2 plus word again. Right now, we are modifying this initial value here into a new one, and we are breaking this immutability as we are mutating the initial variable that we have declared, which is undesirable. Why we want to avoid these type of mutations is because we don't want to keep track of them. keeping track of this mutation can become quite hard if the code gets more complex. It will be harder for us to test the code and also to find any bugs that may arise. So it's preferable when you use functional programming to apply this principle. Now, in Python, there's also this concept of immutability, but it's applied to data types, which may present some challenges when applying this principle. So we have something called immutable data types, which are int, float, decimal, pool, strings, tuple, and ranges. What this allows here, this immutable data types, it allows this example I mentioned here beforehand to work pretty easily, in the sense that when we declare a new variable with another name and assign this variable to an old value, what is being done is a new copy is created for this new variable. So it's going to be quite easy to manage, and maintaining immutability will be easy. But there are mutable data types, which are lists, dictionaries, sets, and user-defined classes. And they become quite a challenge, as we can see in the example below. We have list 1, we have declared as a list of 1, 2, and 3. If we then assign list 2 to list 1, and then modify list 2, we modify the second element of list 2 to a 5, what we're actually doing is to also modify the second element of list 1. Because this equality, this assignation of here is not actually creating a new list for list 2. It is just referencing the same one that list 1 had. That can be quite a challenge in Python, in the sense that we have to keep track of how we manage this. But luckily, we have functions and constructors that let us create new lists or new groups from existing ones, avoiding this kind of stuff. We'll look at that later on with the common functions that we have. But it's something that we have to keep in mind when working with immutability as a principle in functional programming in Python. So now let's take a look at the final principle that I want to talk to you about, which is higher order functions. And they, in general, are quite simple to understand. Right now, this means that functions can accept other functions as inputs, and then they can also give another function as an output. It doesn't have to be like every time we give a function, we return a function, but we can do that also. This way, we can create very complex behavior, in the sense that we can compose functions together and create change of executing functions that can create a more and more complex behavior inside of software. And it also allows us to manage all of the issues that we may find with the other two principles of pure functions and immutability. Let's look at an example of how this is done in Python. Before I show you the example, let me tell you that when a language allows this higher order function, we say that the language treats functions as first-class citizens. So yeah, let's take a look at the example. We have this function called sum5. It takes a number and it sums 5 that number. Cool. And then we have create another function that is called do twice. What we want this function to do is to call any function twice. So we have the function here as an attribute, and then we have any value. And then we return the function that inside calls the function and the value. What this will do, we can see here. Do twice, sum 5 and 5. And then we will have something like that. It will be sum 5 of 5. So if we take the value here, that is 5, will be this first execution will be 10, and then the second execution will have a 15. So when we do twice, in this case, we will have the number 15 as a result. As you can see, having these functions as an attribute, then as I mentioned before, allows us to change that, because then we can do twice of these do twice, for example. And we can do more and more stuff that we want. So yeah, that's pretty much it, the first 3 principles I mentioned you before. So now let's take a look at some of the common functions. This common function exists by default in Python and allows us to apply functional programming code in easier ways. Because if we apply these previous principles I mentioned by ourselves, it may be a bit of a challenge, as there is a lot of stuff that we will need to take into account. And there's already a lot of functions that allow us to apply these principles quite easily without thinking much about like how to manage that in our software. And it will be much easier to test in the future. So let's take a look at the very first function. There are 3 functions, by the way. The first function is map. It's quite simple. It applies a function to a group of values. If we look at the definition in Python, what map does is that it receives a function and then an iterable. An iterable can be anything, something like a list or a dictionary or something similar. And what does this function does is that given the iterable that we have here and given the function, it applies the function to each element of the iterable, like this. And then the result of each of these, the result of applying this function to each element, we compose all of these together and we have a result, a new iterable with the result of each function being applied. So let's take a look at how the Python code would look like. So beforehand, let's take a look how we would do this if we didn't have this function. We have the list, which we declare here. And then we have a for loop that we are going to have. In this case, I want the for loop to also have an index. So I call this enumerate a function that will give us the value and the index. And then we modify each element of the list to have a new value, which will be value by 2. There are a few problems here that we can also find that breaks the functional concepts that we mentioned beforehand. The first, the main one is that we are breaking immutability, in the sense that we are modifying the initial declaration that we have here with new values, which if the behavior will be more complex, it will be harder to follow. Something also to notice here is how this type of coding exists. This case, as you can see, we have some procedural, the code is very procedural, as we are explaining step by step what is needed to be done. We have to explain that there's a declaration, that then there is a loop, and then for each loop, we are doing an operation. Now let's take a look at how this is applied with map. So here we have the list again, which we have declared. We define a function, which is going to be the one that's going to change the value, receives an input, and then multiplies by 2. And then we have the execution of the map, which is going to be in another declaration of list 2. So we call the map, we add the function by 2, and then we add the list. And then something to consider is that the map doesn't return a list in this case. It returns like a generic iterable. And what we have to do is then to construct it to a list. So we add this list call here, so it returns a list. So yeah, that's it. As you can see, the code is quite more compact. And also something that you will notice is the code here, especially in the last part, it becomes more descriptive. We are not giving procedures of how to achieve something, but instead we are describing what we want to do with the code. We can read something like that. List 2 equals the list of mapping at least 1 by 2. And that's kind of it. So yeah, this is the map function. Let's take a look at the next one, which is very similar to this, which is called filter. What filter does is removes value from a group or a iterable based on a specific condition. This condition will be inside a function. So let's take a look at the definition. We have the filter. The filter here, it has a function and it receives an iterable. In this graph, as we can see here, the iterable is here, a list, and then the function has to have a specific property. It has to return a true or false value always. So if the value is true, the result will be kept in the final output of the function filter, and if it's false, it will be discarded. So this function is applied to each of the elements here. As I said, false is being discarded from the output, true is included. So yeah, that's great. Now let's take a look at Python. The traditional way that you could do it is that we have list 1, and then we have an empty list 2, and then we add in elements that the new elements in list 2. So we iterate over list 1 here with the value, and then we check if, for example, if the value is even. In this case, it's value mod 2 equals 0, and then we append the resulting value of the resulting comparison here into list 2. And the result will be having a list 2 that only has even elements. As you can see, again, something that you may notice is, again, this is very procedural. We are explaining step by step what needs to happen for our values to match. And also, we are also breaking again immutability, in the sense that we are declaring list 2 as an empty list, and then we are appending or modifying list 2 to have new values. We are mutating it. Let's take a look how this will look with with using filter. So first we declare a function that is called is even, that makes the check. In this case, the check is to check if it's even. It will return a true or false value. Then we have the declaration of the list 1 that we had here, and then list 2 will be the calling the filter with the function is even of list 1, and then parsing everything to list in the same way that we had with map. As you can see again, this is very declarative, and in the sense that we are describing what is going to happen. We're just going to give me a list of by filtering all elements of this one where they are even, or something similar. Now, this is all for the filter function. As you can see, it's quite simple. It's very similar to the map. And finally, let's take a look at a specific function that is called reduce, and it's maybe the one that is more complicated to understand. What this does is that it transforms a group or a iterable into something totally new and anything that we really want. This is very powerful in the sense that we can have a list, then it could be whatever. It could be a new integer, it could be a string, it could be an object, or it could be another list, really anything that we want. If we look at the definition, we have something like this. Receives a function, an iterable, and then as an optional parameter, it can receive an initializer. This initializer, if it's specified, will determine the data type that is going to result of the reduce function. If it's not added, then the data type that is going to be the resulting element of reduce will be the data type that each element inside the iterable has. When calling this function of reduce, what is happening in the inside is a recursive call of the function. When we have the function that is being applied to an element to the iterable, and that result is being applied to the next function with an element of the next iterable, and that result is being applied to the function again with the element of the next iterable, until we have finished all the elements of the iterable that we had available. So let's take a look at the code in Python and how do we apply this. So we have, first of all, something different from the other ones, map and filter, is we have to make an import. Because while map and filter are by default in Python, and they're available for us any place, reduce actually exists in this library called functools. We don't have to worry to download anything because functools is available in the Python by default, but we still have to import it. This functools library it doesn't only have reduce, it also has other functions that is related to functional programming. But one of the most used one is reduce. So what do we need to have this function to use this? First of all, we have to declare a function, but it's quite different from the other ones. If you remember, for map and filter, we had only one input, right? We should call it X or whatever, and then that input was changed. In this case, we have two inputs. I have called the first one prev, which is means previously, and the other one is current. The first one means it's something like an accumulator. That means like the previous state of the resulting element of the reduce. And current means the current element of the iterable where we add. So let's take a look how it would look when calling it and how it would look if we didn't use it. So we called reduce, then we add the function that is sum, and then we add our iterable. In this case, it's a list. And we have the resulting, which will be the sum of all the elements inside the list. 1 plus 2 plus 3 plus 4 plus 5. So if we didn't use this, or how it will look from inside this reduce will be something like this call. As you can see, it's a consecutive calls to the sum function with each element. So we start with this, the sum of 1 and 2, and that result we add to the sum of that plus 3, and then we have the sum of that plus 4, and then the sum of that plus 5. As you can see, the prev element here is the accumulation of the other results of the function that we added, the sums. And the current element is just the elements of the iterable. Also, in this first example, we didn't use the initializer. So the initial element for this prev attribute will be the first element of the iterable, and the current will be the second one. But what happens when we use the initializer? In this case, we initialize it as 10. Well, we have the same reduce of sum of this list and 10, and what will happen in this call will be something like that. The sum of 10 and 1, and that in the sum of that and 2, and the sum of all of that plus 3. As you can see, the initial value in the first call of sum will be the 10th initializer, and then we have the first element of the iterable. And then we have the other elements called later on. As you can see, this does basically transform, or, well, yeah, as the name says, reduce something to something new, right? To collapse to a list into something new. Something to consider is that in this example, again, I use integers here, but this 10 could have been a string, and then the function could have actually concatenated each value as a string or something similar. So yeah, that's pretty much it for the 3 functions I want to show you. With map, filter, and reduce, you will have a lot of power when using functional programming, and they are more than enough for you to manage any functional code in Python in a general way. And they're quite powerful for us to manage iterables mostly, and also transforming iterables in new stuff. But there's one more topic I want to introduce to you, which is comprehensions. In Python, there is this specific topic called comprehensions. We can define them as a technique and a form of syntax sugar for creating iterables from existing ones. And also, we can say they are in some way a replacement for map and filter, because it does the same thing as those 2 functions. We can have different types of comprehension depending on the iterable. We can have list comprehension, dictionary comprehension, set, and generator comprehension. And why would you want to use it instead of map or filter? In general, is because it can provide a more elegant, simple way of creating iterables. The code usually can be more compact. And also, we usually describe using comprehension as more Pythonic, in the sense that it's more used in the community and in software development. So let's take a look at an example of how it would look like. So beforehand, let's take a look. Let's remember the map usage, and then let's see how that translates to using comprehensions. You have the general map, what we have with the by2 function here. And if we transform this to a comprehension, we will have something like this, which is very short. It didn't require this declaration here. And also it seems to be simpler, but it may be harder to read. So let's break it down. First, we have these closing, opening symbols that will describe what type of iterable you're creating. In this case, we are creating a list, so we use these ones. Then we have the operation that is going to be done for each element of the iterable that we have here. And then we have the iteration, a for loop or a for x in the list that we want to iterate. This will create a totally new list without any issues. That is going to be totally a new one, immutable, and we don't break any concepts. In this part, when we create the operation, we actually can call any other function that we want. We could have called this by2 function if we wanted, but in this case, it was not needed because of the simplicity. But if something is more complex, it's desirable to have more functions, call functions. Something to also consider here is that this is only one statement, and you cannot have multiple ones here. So you cannot have declarations inside of this part, only operating with the x value. If you want to have any declarations or having any returns, you will need to use a function here. So yeah, that's it for how it's described. But we can also use a comprehension as a filter, as I mentioned beforehand. And that will require to use an if statement. So let's take a look at the example below. It's very similar. Again, it has the same elements. We have the x or the operation that we want. We have the iteration here, but at the end, we add an if statement, which is going to filter out all the values in the iteration that do not match this statement. So if the value is even, in this case, we don't want to be processed here. In addition, where we have the operation here, we can also do anything else besides the x. We could have x by 2, and then we will have a list of all the even values by 2. But also, we are not only limited to have the if here, but also we can have an else. But that will change a bit of the syntax. In case we use an else, it should look like the one below. So we have an x here, and we have the if use x if the value is even, else use a 0 for the values in the list 1. So yeah, that's pretty much it for comprehensions. As I mentioned, this is preferable to use besides map and filter. and actually it provides more compact code. So yeah, that's pretty much it for all the topics I wanted to cover with you today in the sense of functional programming and how it's applied in Python. As a final note, let's talk about some considerations that we have to take into account and some lessons that we can take. First of all, that the functional programming code is going to be the developer's responsibility in Python in general, because we don't have like a check that says our code becomes fully functional. Instead, we have to take into account which principles we want to add and which elements we want to take into account and how we are going to do it. But that may seem a bit as a disadvantage, but also it can help us create more dynamic code and also increment or make our code functional as we go along with it. So it's, again, it makes that functional programming is not an all or nothing in Python, and then we can decide where it's best to use it. Also, these functions that I show you, map, filter, reduce, and also comprehensions are great, but they are usually limited to creating iterables from existing ones or transforming information to another information, or one data type to another data type. So if we don't want to do anything like that, instead we want to just make a for loop and some operation there that doesn't create something new, a for loop or something similar option, as long as we try to avoid mutations. And finally, we have that, well, as you may have seen, the functional code can be more compact, but also, and that is a double-edged sword for us, in the sense that we make it less readable. So we have to be careful in that sense. We have to try to make, if we reach a point where the code is way too compact or hard to read, it's a good idea to break it up. Usually, when breaking up, we just create more functions for it, and then call these functions inside of function code or inside of calls of map, filter, reduce, or inside comprehensions. But yeah, that's pretty much it for this talk. Thank you for listening. And if you have any questions, let me know.
Yeah, thank you, Alexander, for taking the time to talk to us. I can kick off with a question maybe. So you had talked about how list comprehensions can often be more elegant or in concise way than like using map, a filter, reduce directly, right? I might have missed this, but I'm wondering, is there any like difference in performance between those two options?
So actually, you won't find major difference between using a map or a list comprehension. If I remember correctly, you may find a small increase in performance. You have a lot of data using list comprehension, but it's not because of the map itself, but it's because you have to have this list called here. It's because map doesn't return this type that you want. It's going to return a generic iterable that you have to transform into the data type that you want. So this transformation here may increase a little bit of the performance, but in most use cases, it's nearly negligible. So you won't find a much issue with it.
Okay, thank you.
Does anyone else have any questions? It seems not.
Yeah, so then I just want to thank you, Alexander, for sharing your time with us. I think this is very applicable talk because I'm pretty sure everyone here programs in Python. So hopefully we can start to take more of those functional features that we're learning about in this conference into our Python code. So thank you for giving us your time today.
Yeah, for sure.
Thank you so much. I learned a lot.
That's great to know.